Hello everyone, I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Today I am here to discuss about a particular method of solving a system of linear equations. Now there are various methods available to solve a linear system such as Jacobi's method, Gauss's method, Gauss elimination method, or Euler's method, or Martin's rule, which involves the use of matrices, then Newton's method, Horn's method, various methods are available. But today in particular we shall discuss the Cramer's rule, the method known as Cramer's rule to solve a system of linear equations. Now this particular method involves the use of determinants. So we shall be using determinants to solve a system of linear equations involving two unknowns and also more than two unknowns, and the method is known as Cramer's rule. So let me explain the method. Let us start with a system having two unknowns, two variables. So if we have a linear system given by a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. So here we have a linear system involving two unknowns x and y, and these are the coefficients. a1, b1, a2, b2 are the coefficients of the system, as you all know, and c1, c2 are the constant terms. Now to solve this system means we have to find a value of x and a value of y which will satisfy both these two equations simultaneously. So such a pair of values of x and y will be called a solution to such a system. So the Cramer's rule suggests that first we have to form a determinant, which we usually denoted by d, formed by the coefficients of the system. Coefficients means the constants arriving with the variables together with the sign. So they are the coefficients a1, b1, a2, b2. So first we form the determinant a1, b1, a2, b2, which is also known as the coefficient determinant of the system. And we also expand this to find the value. As you all know, it is a 2 by 2 determinant. The expansion rule is given by a1, b2. First we multiply diagonal wise a1, b2, then minus of this way b1, a2. So this is the value of d. Then we have to form dx. The next determinant we shall call d suffix x. So as x, the variable x, occurs in the first column of the system, so how to form dx? Dx is formed from the coefficient determinant d itself by replacing the first column of d, that is a1, a2, by the constant column c1, c2. Why we are replacing the first column? Because the corresponding variable x occurs in the first column of the system. So we shall replace the first column of d by the constant column c1, c2, the second column remaining as it is, that is b1 and b2. So this is the next determinant dx, which upon expansion shall give c1 times b2. First we multiply diagonal wise c1 times b2, then minus b1 times c2. So this stands the value of dx. And then we also find another determinant d suffix y, similarly formed from the coefficient determinant d, and this time we shall replace the second column of d, that is b1, b2, by the constant column c1, c2, because the corresponding variable y occurs in the second column of the system. So dy is given by a1, a2, the first column of d remains the same, the second column is replaced by the constant c1, c2, so which upon expansion gives us a1, c2 minus c1, a2. So these are the values of d, dx and dy. So after obtaining the values of d, dx and dy, finally the solution of the system will be given by the variable x is given by dx divided by d. This shall be the value of x, and y should be given by dy divided by d. This should be the value of y. So this is how we can solve a linear system involving two variables using Cramer's rule. This is known as Cramer's rule. Named after the mathematician Kramer, who invented this method. And the same can be extended for a system of linear equation containing more than two variables. Let me now show the same method for a system involving three variables, that is x, y and z. So we now consider a linear system in three variables given by a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. So similarly, we have to form the coefficient determinant d, which should be a 3 by 3 determinant, a determinant of third order formed by the coefficients a1, b1, c1, a2, b2, c2, a3, b3, c3, followed by the determinants dx, dy and dz, where dx should be formed from the coefficient determinant d by replacing the first column by the constants d1, d2, d3. Why? Because the variable x occurs in the first column of the system. So this should be d1, d2, d3. The second and third columns remaining the same. Then we have dy, which is again formed from d by replacing the second column by the constant columns, because the variable y occurs in the second column of the system. So this is given by a1, a2, a3. The first column of d remains the same. The second column b1, b2, b3 is now replaced by the constant column d1, d2, d3. And again the third column remains the same, c1, c2, c3, that is dy. And similarly we have dz, again formed from d by replacing the third column by the corresponding constants. So here we have a1, a2, a3, b1, b2, b3, and then d1, d2, d3. Then we have to expand all these four determinants to find their respective values, and finally x will be given by dx upon d, y given by dy upon d, and z given by dz upon d. So this will be the set of values or the set of solution to this system. So this particular method is known as Cramer's rule. We can also extend this for a system containing 4 variables and 5 variables likewise. But for a system containing more than 3 variables, the Cramer's rule method will be a little bit laborious. So instead of doing Cramer's rule, there are other methods likewise Euler's method or Gauss-Jordan method or the matrix rule, Martin's rule. Those will be much more useful, because the expansion of the determinants of fourth order, either we have to apply the Laplace expansion, that will be also tedious to do. So there will be lots of calculations involved if the number of variables exceed 3. But theoretically it is possible, practically also it is possible, but it is not suggested. This method is not suggested if the number of variable exceeds 3. So this is how to solve a linear system involving 2 and 3 variables using Cramer's rule. I hope the solution is clear to you. If you have any doubts, you can ask me in the comment section, and thank you all for watching my video.